In this lecture, we're going to walk through how to implement a CI/CD workflow using Databricks Asset Bundles, or DABs. We'll cover how to plan a project, set up testing strategies, and deploy workloads efficiently across different environments. To start, let's discuss what CI/CD is and how DABs streamline the process. Continuous integration, or CI, automates code integration and testing, while continuous delivery and deployment, or CD, ensures code is always in a deployable state. Databricks Asset Bundles simplifies this process by allowing us to define, version, and deploy assets in a structured way using the Databricks CLI. When planning a project, it's crucial to define deliverables, tasks, and Databricks assets. So deliverables are answering the question, what are we building? Tasks are answering the question, what are the key steps to achieve this? And Databricks assets are answering the question, what components are required? In this case, we are visualizing health data. The key tasks include ingesting a daily incremental CSV file into a bronze layer, cleaning the data into a silver layer, and then creating a gold table to share with consumers. Now that we have an understanding of our project and our data, let's dive into the project setup by first looking at the individual isolated environments, dev, stage, and prod, shown here. In this project, we'll create a catalog for each environment, dev, stage, and prod. The dev catalog will contain a small, static subset of our production data used for development and initial testing. The stage catalog will hold a larger subset of production data, enabling more comprehensive testing as we move through our CI/CD process. Finally, the prod catalog will contain the live production data that we will rely on for final operations. Our workflow starts by developing on the dev data, running unit and integration tests as we progress through the pipeline. The pipeline is set up with Databricks workflows, which execute the unit tests, DLT pipeline, and final visualizations. As we test the pipeline through each stage, we will ensure everything is functioning correctly before deploying to production. In this project, we will be deploying a DLT pipeline using DLT expectations. This will help with the integration tests. Within CI/CD, there are testing steps that you should be aware of in what's called the testing pyramid. The testing pyramid categorizes different tests: unit tests, integration tests, and system tests, as shown here. Starting off with unit tests, these are going to be things like custom PySpark functions, and these are fast, low cost, and high coverage, and also automated. Next are integration tests. These are things like notebooks, DLTs, and job interactions. And next we have end-to-end data pipeline and workflow. And these tests are for the entire application with the goal of ensuring that all parts function together in a cohesive way. Next, let's talk about PyTest as a unit testing framework. PyTest, as defined here, is a popular testing framework for Python that makes it easy to write simple and scalable test cases. It has simple syntax, provides assertions, has automatic discovery, and a rich ecosystem. So the idea is that you don't need to worry about a complex setup. PyTest leverages Python's built-in assert statements. That makes it simple to use, but provides detailed error messages when a test fails. In addition, there's no need to manually configure which tests to run. So whether you need to test coverage reports, parallel test execution, or integration with other tools, there's a plugin for almost anything. This course provides a simple introduction to PyTest. There are many other testing frameworks available, so just select whatever fits your organization's needs. Next, let's take a moment to review DLT expectations for integration tests. So Delta Live tables expectations are data quality constraints that validate data as it flows through your ETL pipeline. By defining these expectations, you can ensure that your data meets specific criteria before further processing. They allow you to automatically verify that data transformations and pipeline logic produce the expected outcomes. So by incorporating expectations into your DLT pipelines, you can detect and handle data quality issues early, ensuring robust and reliable data processing workflows. Next, let's take a moment to look at a high-level view of CI/CD and DevOps. On the left, we have continuous integration, or CI, and on the right, we have continuous delivery, or continuous deployment, or CD. The process here goes from develop to build to test to version control, and then we start thinking about how do we actually deploy this into our staging environment? What does the staging environment even look like, right? And then we talk about, well, how do we deploy this to production? How can we do this in an automated way? And that's kind of the power of DABs, or Databricks Asset Bundles. So the idea with DABs is we want to automate this process in each individual environment. So whether that is develop, stage, or prod, or maybe you have a QA in there, or some kind of in-between environment. Dabs are a powerful tool for implementing CI/CD in a Databricks project. They provide an infrastructure as code approach to managing Databricks resources, making it easier to version, deploy, and collaborate on data and AI projects. Dabs support defining multiple deployment targets, making it easier to manage different environments and their specific configurations. So for example, here, if you want to think about development, all we need to run with the Databricks CLI is Databricks bundle deploy-t development. If we want to deploy to the staging environment, we have Databricks bundle deploy-t stage. And similarly for production. By leveraging dabs for CI/CD, data teams can adopt software engineering best practices to improve collaboration and streamline the process of deploying and managing Databricks projects across different environments.